Hello students, this is video 4.1 and the unit title is Rooftop Triangles, and the objective is students will be able to identify convex and concave polygons, and students will be able to identify interior and exterior angles of a polygon. Your IXL skill is G4. Alright, let's go flippers. So this lesson is going to start off with a definition about what a polygon is. So a polygon is a closed figure with at least 3 different sides. And if you look at the examples that I've drawn here, here's an example of a polygon. It's got 3 sides if you count them 1, 2, 3. Here's another example of a polygon. This actually has 5 sides, excuse me. And then this final one, this is also a polygon too. If you count the sides, you'll see it has 1, 2, 3, 4, 5, 6, 7 sides. Okay, and it is a polygon because it's a closed figure. So that has 7, this had 5, and this had 3. Okay, so now there's another way to classify polygons, and that is by if they are regular or irregular. So let's look at actually the regular polygons, and then we'll talk about irregular polygons. A regular polygon is a polygon where all the side lengths and angles are congruent. So here we have a square where all the side lengths are congruent. We can do that by marking this. Okay? And all the angles are congruent as well, meaning this angle is congruent to this angle and this angle and this angle. Okay? Now, if we look at the figure next to it and we mark that these angles are all congruent and these angles are congruent as well, and then we can mark that all these sides are congruent to each other. That would mean that this is a regular, and if you count it, it has 6 sides, so this is actually a hexagon. So we have 2 regular polygons, one being a square and another being a regular hexagon. An irregular polygon is going to be just the opposite of a regular, which means that you could have all the sides be the same, but the angles would not all be congruent. Okay, or you could have some of the angles be congruent and then the sides not be congruent. So we can look at this and see that there's no markings on this, which indicates that none of these side lengths are the same. So visually, if we think maybe this is 3, this is 2, this is 5, and this is maybe 7, we can see all these side lengths are different. And more importantly, we can also see that the angles inside are also going to be different. Even if these 2 angles happen to be the same, these 2 angles would clearly be different here, here, and here. So this makes it an irregular polygon. What I want to talk about is a convex polygon. A convex polygon is a polygon where all the interior angles are less than or equal to 180 degrees. Okay, so if we look at this polygon, this is a convex polygon. Every point on every line segment between 2 points remains inside. So if I were to draw in a segment from every vertice, so from here to here, you can see there, that's inside, here to here, here to here, and here to there. Okay, and we could do this for every single one, and we'd always get them to remain inside of the actual polygon. Okay, so that makes this a convex. And we also want to point out and remember that all the angles that we see in this picture are less than or equal to 180 degrees. That makes it convex. It's vexed, man. Get vexed. For a concave polygon, I like to think of that word as cave, meaning this polygon could cave in. Okay, so there's going to be at least one interior angle for this polygon that's going to be greater than 180 degrees. But if you look at it, you can find it right away. Yep, you're right, you found it. This angle is way bigger than 180, so that angle makes this polygon concave, which to me makes me think it could cave in. Ah! Also notice that if you try to draw a line, okay, between every vertice in this concave polygon, it will actually go outside of the polygon. So here we go. So we pick a vertice and try it. Okay, so let's pick this vertice here. All right, so if I draw a segment from this vertex to all the vertices, so it works, it stays inside. This one, it stays inside. This one, it stays inside. But for this one, it's outside of the polygon. So that makes this one, again, concave. So there's two important theorems that we need to talk about for only convex polygons. Okay? So not the ones that will cave in, but the ones that are cool, that will not cave in. Okay? So a polygon angle sum theorem says that if a polygon is convex, then the sum of the measures of the interior angles of the convex polygon within sides is n, the quantity of n minus 2 times 180. So let's take, for example, a triangle. The triangle has three sides, right? 1, 2, 3. And we know that for a convex polygon, which it is, okay, with insides, the insides we're going to change to 3. So this would mean 3 minus 2 times 180 will give us 1 times 180, which will give us 180, which means that this is the sum of the interior angles of this polygon. Which should make sense to you because most of you know that already. So now let's look at the polygon exterior angle theorem. If a polygon is convex, okay, then the sum of the measures of the exterior angle, one at each vertex, is 360 degrees. The sum. So in essence, what that means is no matter if you're dealing with this figure here that has 5 sides or this figure that has 3, if you add up these 3 angles in this picture, okay, the exterior angles, meaning this angle 1, angle 2, and angle 3, that those 3 angles will add up to 180 degrees. Whereas here, if you add up to angle 1, angle 2, angle 3, angle 4, and angle 5, which are also exterior angles, these will all add up to 360. Okay? So if you think about it, these angles, you'll see that the exterior angles for the figure with 5 sides are probably going to be smaller than the exterior angles for the picture with 3 sides because we're spreading 360 over 3 angles instead of spreading 360 over 5 angles. Now, I want you to think about something for a second. 180 for every triangle. So let's say we have a pentagon. And with that pentagon, we prove that it's convex. So we can now figure out the interior angles. So let's say we take this convex polygon and we draw lines from every vertex to every other vertex in the triangle. So here we go. We're going to do it here, here, and we already have all the other ones, right? We got one here, one here, one here, and one here. Okay, so we're actually just doing this for one particular vertex, and that will be here. We'll call this vertex A. Now, if you look at this, we just split this into what? You're right, 3 different triangles. 1, 2, 3. And we know that each one of these triangles has a total of 180 degrees inside. So if we wanted to figure out the total interior angles of this pentagon, we could just take this 3, right, because there are 3 triangles here, and multiply it by 180, and we'll end up with, that's right, 540. Now, why is this important to you? Well, it actually explains the polygon angle sum theorem, okay? Because this over here, if we had counted this and used the actual formula a moment ago, the theorem, which says that for n sides, well, this has 5 sides. Well, 5 minus 2, right, because it will be n minus 2 times 180, actually turns out to be 3 minus 2. So what this is doing is it's saying that if you have a 5-sided figure, and we do, and it's a polygon that's convex, and you could add in 2 additional lines on the interior, which we did, okay, that actually means you're going to have 3 complete triangles inside times 180 to give you 540, okay? Really cool. Example number 1 says, which is the measure of an interior, so I want to add the word interior, angle in a regular pentagon, okay? So we remember that a pentagon, we know this is regular, so we know that all these angles are going to be equivalent and have the same measure, okay? So that means that we can use our n minus 2, quantity of that, times 180. So we would end up with 5 minus 2 times 180, which will give us 540 for all of them. And now we need to take that 540 and divide it by 5 because there are 5 angles. And we'll end up with, that will give us 108 degrees. Remember, all of these angles, interior angles, are going to be 108 because this is a regular polygon. Number 2 says, classify this figure as convex or concave and regular or irregular. And we're talking about the figure from example number 1, okay? Meaning you should have drawn it. Yes, you should have, okay? We know that this is going to be regular. Why? Because all the angles are the same, and we were told it's regular. And we also know it's going to be convex because, again, if we take this figure and look at it, we can draw a segment that stays in the interior of the figure from every vertex. So here to here, this vertex to this vertex to this vertex. And we can do this for every single side, every single vertex. And we would never, ever go outside of the figure. Convex, making it convex. Question number 3. What is the sum of the measure of the interior angles of a polygon? A hexagon on the left. Okay, so we know that this is a hexagon. We don't know if it's regular or not, and that really doesn't matter. But we know a hexagon has 1, 2, 3, 4, 5, 6 sides. So we can go ahead and say that 6 minus 2 times 180 will give us the sum of the measures of the interior angles, which will give us 4 times 180. And we know that 180 times 2 is 360, so if you double that, you will get 720 degrees, and that is our answer. Last but not least, number 4, if each exterior angle measures 20 degrees, how many sides does this polygon have? The clue here is the word each, okay? So what they're saying is if each exterior angle measures 20 degrees, which means that every angle in this figure, no matter how many sides it has, well, obviously it has more than 3, but every single angle on the exterior, right, or we're talking about exterior angles, which would be there, right, exterior angle, which would be here, and the last exterior angle would be here, okay? All of those add up to 360. And if we know they all are 20 degrees, if we take 360 and divide by 20, we will the number of sides that this polygon will have. And that number actually turns out to be 18. And that's a pretty cool polygon. So here we've made it to your secret hot question. It says find the measures of y and z. I want you to think about this question. Look at the relationship here that will help you figure out z, and then you should easily be able to find y because you know what type of figure this is. All right, and remember to work on your IXL skill G4. Later, dudes.